How do you check to see if this is the correct answer, Andrew? What do you do to it? So if you take the derivative of that, what is the derivative sign? So it's cosine of what's inside, but then because of the product rule, what do you have to multiply by? The derivative of x squared. What is the derivative of x squared? 2x. So that's where the 2x comes from. So you have cosine of x squared times 2x. Is that the same thing as that? Yes. Okay. Yeah. Oh, yeah. The order is different. Okay. So let's change it up. Let's just change it up just a tiny bit. I'm going to give you 10 seconds to write down the indefinite integral. That isn't indefinite. They're going to be, Chris. Negative 2 cosine x squared plus c. Now, why is there a negative on the outside?
Because antiderivative sign.
The antiderivative sign is negative cosine, right? And why is there a 2 out front?
Because when you do the chain rule,
you
get 2x.
Yeah, no, 2x, not
4.
So you want to turn 2x into 4x, so you multiply it by 2. So some of these you can do like this. You can do more complicated integrals. Some of them you can do without any sort of added notation. You can do it just straight out, effectively in your head. You're like, oh, okay, there's an x on the outside. Here's the big tell, everybody. Here's the big tell. What's the power of the thing on the inside right there? 2. What's the power of the thing on the outside? What's the difference in those powers? The difference in powers is 1. The big tell that you're going to use this new method called w-substitution is going to be a difference in power of 1. There are other tells, but that's the big one. That's the big one. So let's to the 4t, right, plus c. Well, 1 over ln e is just what? 1. So you guys think that the answer to this is itself. How do you test to see if that's the right answer? Yeah, so if you took the derivative, what is the derivative of e to the 4t? ln e times 4 because of the chain rule, right? Is there a 4 on the outside of the original integral? No. So try again, everybody. You have 10 seconds to fix it. Go. You ended up first trying, oh, maybe the answer is e to the 4t because a lot of things tend to be the same when you're dealing with e. But if you took, what is the derivative of e to the 4t plus c? What's the derivative? Yeah, 4 e to 4t. That's the derivative, right? But is that the original thing right here? What's the problem? So you want what on the outside to take care of that 4? It's going to be 1/4 e to the 4t plus c. Does that make sense, everybody? Does that make sense?
Yeah, I was just confused on it because we always did the 1 up.
Yep, that's not how you do it here because it's totally different. It's not the same rule at all. Okay, so let's make it, I'm going to make this one a star. So I'm going to change it up just a little bit. So it's just a little different. Let's say I gave you the integral of, what's new about this one here? Oh, it's not, well, that's not new. I do that all the time. What's new about the structure of this one? What's new about the structure of it? There's a t squared and there's a plus, so there's this, right? And is there another t in there? Yeah, t is in 2 places. I told you, though, that there's something about that representation that makes it should make you feel good. What is it? The what? That's the name of the lesson we're doing, but I told you about 2 minutes ago. There's something about those two things. The difference of powers is 1. What's the power of the, it's t squared plus 1 on the top, and it's t over on the bottom, right? Okay, so do me a favor here. Erase what's on the board. Let's take a look at what you put down, David. You put down, you think the answer is, what was it? 1/2 what?
E
to the?
To t squared plus 1.
To the t squared plus 1. How would you test to see if this is right?
Factor it out.
Not factor it out. No factoring. How do you test to see it? You take the derivative, right? So let's take the derivative of this, right? What's the derivative of e to the t squared plus 1? What's the derivative of this right there? E to the t squared plus 1 times what?
2t.
Times the derivative of t squared plus 1, right? Correct? And there's a 1/2 on the outside because that just stays there, right? What's the derivative of t squared plus 1?
2t.
So what do you end up with? 1/2 times 2t times e to the t squared plus 1. Is that almost exactly what you want it to be?
Yeah.
David, in this case, I see what you were doing there. You noticed...
4t?
No, look. If you cancel this, it turns into that, right?
Yeah.
The 1/2 causes a problem. So what do you just not put in the original answer? What don't you not want to be there? You don't want the 1/2 to be there, right? So what's the actual answer? Oh, sorry. What's the actual answer to this going to be? You don't want the 1/2 to be.
T squared plus 1.
Yes. The answer to this is e to the t squared plus 1 plus c. Exactly what you were about to erase and create. The point is that, oh, sorry, I didn't see it over there. That's about the limit of my vision. But yes, you're absolutely right. Here's the point, everybody. The reason I wanted you to stop erasing is that's exactly the kind of process you're going to go through in your head. You're going to go, oh, I'm off by a factor of 2, so I'll multiply by 1/2. Oh, I'm off by a factor of 1/2 or 4 or 6. You multiply by the opposite of that. The key tell, though, what was the key tell that this one was nice? What was the key tell, Natalie? The difference in powers is 1, right? It goes from t squared to what? To t. That's a really nice thing. So let me show you the notation you can use to make this a little easier for you. And again, there's no magic bullet because you have to choose your substitution. And are you always going to choose the right substitution the first time? Say no, you're not going to. So it's called w-substitution. When I was in math, we called it u-substitution. Some books use u, some books use w. Does it matter which one you use? No. But I kind of like w because it looks different than the other variables. Even though I will sometimes default to use u because that's what I was imprinted with. I don't know. Our w is going to be t squared plus 1. You're going to watch the process, then ask questions, okay? If I took the derivative of both sides, what does dw dt equal right here? What does dw dt equal? Take the derivative of the right-hand side. 2t, right? So what does dw equal? 2t times what? dt. Are you with me so far? Are you okay? So let's do that substitution. It's the integral of 2t e to the what power? E to the what power? E to the w. And instead of dt, what do I write? What does dt equal? What does dt equal? dw over 2t. So this is dw over what? 2t. Hey, does something cancel? The magical thing that you are looking to be able to do when you do w substitution is exactly what I did. Oh, look, it just nuked that, right? So what am I left with? The integral of what?
EW times DW.
E to the w times dw. What is the integral of e to the w? E to the w plus c. But what does w equal? So it equals e to the t squared plus 1. Oh, is that the exact same answer we came up with?
It fits in too well.
Isn't it really nice? So here's the thing. The reason, so it should, I like that it makes you feel a little uneasy because you're like, that's just way too straightforward, right? What's the friction that I eliminated? I told you that, are you always going to pick the right thing the first time you pick it? No. I chose w equals t squared plus 1. I've had practice. I've done this one 1,000 times. But the point is, if you pick the right thing, will it go kind of nicely? What are the signposts? What's one of the signposts that tells you you're moving in the right direction? What did I explain it to you? How did I explain it to you? What's that first signpost? You're moving in the right direction. See this? If you get to a point where you're canceling something like that, really nice, that's a great sign that you've picked the right thing. You might, though, have to go back and pick something else to be the w substitution. I might say u substitution. It's the same thing. So the trick, what's the big tell here? What's nice about this one? What do you notice first about this one? Yes, I understand that's what the problem is, but what aspect of the problem is interesting? There's a 4th power and a... Okay, those are the things. So why are those interesting? There's a difference of power of 1. So you've got this thing, the radicand underneath right here. In general, again, these are all generalities. These are not hard, fast rules. This isn't like long division where you do the same thing over and over again. But in general, you want everything underneath the radical to be the w. In general. So let's do that there. So if I just pick that there, what does that mean w is going to be?
X to the 4 plus 5.
Plus 5. So what was that second step? What did I do once I found the w, David? What did I take?
Derivative.
Yeah, so I can just do it this way. dw is going to be 4x cubed times what? dx. Is everybody okay with that? I'm just putting the dx on the other side. Is everybody with me? What does dx equal?
Sorry, but dx, like...
I skipped a step, so no, it's not okay. Okay, so dw over dx, I did the derivative with respect to x, is equal to 4x cubed. So what does dw equal? 4x cubed times dx. Exactly, right. So usually what I'm going to do, everybody, when I do it, is I'm just going to say this. I'm just going to go straight to that. dw is equal to 4x cubed dx.
Okay.
I'm usually going to write that just to prepare you. Do you understand where that's coming from? We okay with it now? We good? What does dx equal? Yes. So after you write that out, I like doing each of those three things. Take the derivative and isolate the differential. These are called differentials, by the way. These are called differentials. What did I do once I did that? Do you remember?
Yeah, you wrote it out again.
Yeah, so it's x cubed times the square root of what? W times what? Okay, so that's nice. So what was the next thing we'd like to try to do? Is there something we can cancel?
Yes.
Yeah, what can we cancel? We can cancel the x cubed. What's still there though?
4.
Where do we pull that to get rid of it, but not kill it? Where do we put it? 1/4 in front. The square root of w dw. What power is the square root of w? So it's this, the w to the 1/2 dw. What is the integral of that? Raise your hand when you can tell me what it is. Don't write anything down. Just, is there a 3/2 out front of that? No. So what do I need to put in front?
3/2.
Nope. Close. What do you multiply 3/2 by to get 1? 2/3. Plus what? Plus what? C. But what does w equal? Look at
4x plus 5.
x to the 4th plus 5. So what's what? I know. No, it's fine. It was close. It's close enough. It was close enough. So what do you get here? 2/3 times what? X to the 4th plus 5 to the plus.
C.
That would be your final answer right there.
What happens to the 1/4?
Oh, times. Yes. Excuse me. Times 1/4. Yes. Like that. Absolutely. So you could leave it like that. You could simplify a little bit. That right there would be totally perfect, because what would that answer communicate to me? All of the pieces really nicely. You could cancel the 2 and the 4 and make it 1/6. Absolutely. Can you distribute that inside this? Just say no. You cannot distribute that. Why can't you distribute the... Because there's what? There's a thing up there. Yeah, stay away. Like, I didn't think you could do that. That's crazy, Mr. Steven. No. So here's the thing. Again, is this relatively straightforward once you're on the right path? Absolutely. So you've seen some signposts to what would be, you've seen some signposts that tell you you're on the right path, the canceling. So what would a signpost be to tell you you're not on the right path? There's no canceling. So the reason this is nice is, here's the thing. We are in single variable calculus. How many variables do we need in our integrals? 1. Either x or what? W in this case. Either x or w. Or t. Yeah, we might be in terms of t, but we want one variable, right? In this split second, how many variables do you see in this one? There's eventually 1, but we started with 2, right? But what did we cancel specifically? We canceled the other variable, right? If you end up with something where you can't cancel one of the variables, you need to look at what you were substituting. How do you know which variable you want to end up with? This. See this right here? If you're substituting in w, exactly, David. If you're substituting in w, you want it to be entirely in terms of w. If you can't, then something went wrong, either algebraically or you picked not the right thing to start with. Let's take a look at one that changes if you feel good. It's not a difference of 1, right? Do you see that, everybody? It's not a difference of 1. So let's say you just tried doing this. Let's just try it, okay? I told you, what do you assign to be w? Lindsay, what did I tell you want w to be? Exactly. So w is going to be x to the 4th plus 5. You're cruising along. So what does dw equal?
4x to the 3rd.
Dx, right? And what does dx equal? Yeah, exactly. So you're cruising along and you're like, okay, x squared, like that, right? Times the square root of what? Times dw over what? 4x cubed. So you're like, okay, well, I can cancel something, right? There's something. Oh yeah, there definitely is something I could cancel. Not all of what you want, right? But what are you left with? You're left with, and then times what? So the 4 got pulled out, so what's left? So you have dw and then 1 over what? 1 over x. So this is exactly what I was trying to tell you about here. This is exactly what I was trying to tell you about. So if I rearrange this to make it a little prettier, you end up with, and again, it's subjective, not 1 over w, 1 over what? X times the square root of w dw. What's the fundamental issue with you guys trying to attack this? There are 2 variables, right? How many variables do you want there to be, Chris? 1. You want there to be 1 variable, and in particular, which variable do you really want to get rid of? You want to get rid of this, right? There's 2 variables. You have the dw, whatever the d is, dw, you want everything to be in terms of that. So what is this going to be? E to the what?
Cosine theta.
Yes, plus what? Plus what?
Sine theta.
No, just plus C. Because look, right? Look, when you take the derivative of this, it's still e to the cosine, right? But what does the chain rule tell you to do? Derivative of cosine is sine. Done, right? So this looks horrible, right? Is it actually really straightforward? Yes. So you will notice it. Oh, look, e to the cosine, right? Does everybody understand why this is the answer?
Yes.
Yes.
Is the derivative of cosine negative sine though?
Oh, so what do you need on the outside?
A negative.
Boom. Awesome. Derivative of cosine is negative sine. You're absolutely correct. Good job. Good catch. Awesome. I know we were so happy, and then Natalie had to ruin it for us. It's okay. Well, actually, OneNote is ruining it for me right now by just freezing up. Okay. So here we go. Let's look at another one. Oh man, that looks just not cool. That just does not look cool. It doesn't look cool? Does it not look cool? Really? It doesn't look cool? I think it looks pretty cool.
Isn't that 1 over 1?
Isn't that 1 over 1? What do you mean? How's that 1 over 1? Let's use w-substitution to make this look a little bit better. Does that sound good?
Yeah.
So there's no radical. There are no powers less than each other, right? It's almost 1. For big values of t, it's 1, right? Arvin, you are right. What's the limit as t goes to infinity of this thing? 1. Yeah, that's kind of cool. That is 1. That's true. I'm just going to show you. Let's let w equal e to the t. What's dw equal in this case? Times dt. Do you agree? What does dt equal? Okay, so now after we've isolated our differential, what did we do next? We substitute. Oh, okay. So it's going to be integral of what?
W
Over
1 plus W
times
dw
dw over what? Are you with me so far? What's the problem there? Give me a sentence.
We can't cross
There's
out.
2 variables.
There are 2 variables
So you can't.
in the equation. Yeah, so we can't integrate. There are 2 variables. But what do we know? Look what up here. What do we have right here? What does w equal? W is equal to what? So this right here is equal to what?
W.
So what can I cancel that with?
W.
Can I cancel that like this? So what do I end up with? The integral of what?
dw over 1 plus W.
So 1 over 1 plus w times what?
dw over 1.
So what is that? That is the integral of 1 plus w to the what power? Negative 1. Can you tell me what the integral of that is? If I just gave that to you right there without any preamble, if I just gave that to you, you know instantly what the integral of that is. Instantly. What's the integral of x to the negative 1, everybody? ln of
Value.
x plus c, right? You had to memorize that on a quiz and you were using it. Okay, so what's the integral of this right here?
Ln absolute value.
ln of,
1 plus W.
yep, plus what?
C.
But what did we know w is equal to up here?
E to the T.
So the answer to this is ln of 1 plus
E to the T.
plus.
C.
The key lesson here, everybody, you see the highlighted yellow? Do you see the cancellation we did right there? You can substitute more than once where convenient. If we decide that this is what we're going to substitute, where could we use it? Anywhere we want, right? Oh, so when you run into the wall of you can't cancel, go back to here and be like, are there any tools? Are there any tools? I was really hoping on this one right here that there was something we could use. Like, technically, did we substitute down? Technically, did we substitute down to 1 variable right there? Yes, but was it helpful when we got to this green box? No. Was there any way to simplify that nicely? No. But over here, when we did it end up substituting nicely? Yeah. How do we test to see if that's the right answer? Yeah, you take the derivative with respect to t of this. So that's 1 over what? 1 plus e to the t, but then you have to multiply by the derivative of the inside. What's the derivative of the inside? E. Oh, is that exactly what we want it to be? Uh-huh. Natural log is a hugely helpful function. And what happens what about x to the 1 and x to the 0, right? Can I rewrite this one?
Yeah.
How could I rewrite this one? This would be x to the
0.
times e to the... So look, there it is. Is that one, should that one make you feel good or bad? What do you think? I like how we're putting value judgments on math equations. What about this one? Oh, come on. What's the integral of e to the x?
E to the x.
So what do you think the integral of this one is?
E to the negative x.
Close.
E to the negative 2x.
So what'd you say? What's the answer to this one? Negative e to the negative x plus c, right? Because when you take the derivative, it's going to kick a negative out, but you want that negative to go away. Okay, good or bad? What do you think about this one? Why is this one good or bad? And yes, we're still making value judgments. Why is it good? Oh, power differential is 1. Let's keep looking. What about this one?
Can you substitute that?
Sure, why not? Let's try it here. David, what do you think the w substitution is going to be on this one? Just tell me.
5 minus 2x.
Sure. W substitution is great to help you keep track of things to make them look simpler. Sure. What's dw equal, David? You can do it.
X.
Close. What's the derivative of 5? 5 minus 2x. What's the derivative?
Negative 2.
Negative 2 dx. Exactly. The derivative of that is negative 2. Okay, so what does dx equal?
dw for negative.
So we've done this. We did this a bunch before. Now we substitute. So it's going to be the integral of cosine of what? Times
dw
over. What can we factor out to the front?
negative 1 over 2.
Negative 1 over 2. So, what's the integral of cosine, everybody? So you have negative 1/2 times. What's the derivative of cosine is? Lindsay, you said it. Negative sine of w, right? But what does w equal? Oh, the negatives cancel, right?
Yeah.
I'll keep the, yep, they cancel. So you end up with 1/2 of sine of what? 5 minus 2x.
C.
Done. So yes, you can substitute like that. Now here's the thing. The whole reason for doing that is to help keep track of stuff. Remember how you were like, oh, the 1/2 was there and then David erased it because he saw that it needed to cancel? Sometimes there are too many things to keep track of, so you need something to help you here. What about this one right here? What do you think? Hold on. So I'll clean it up. So W is 2r plus 4. Everybody finish that for me with that substitution. Give that a try. What does dW equal here? 2dr, right? So what does dr equal?
dr equals 2 over dw
Over 2. So after we do that, the next step is to substitute. So you have the integral of w to the times dw over. What do you factor out?
Oh, I see.
1/2 w to the 7th dw.
Yeah.
And is that something you can definitely integrate?
Yeah.
Yeah, it's 1/2. Sorry, this is just having a freak out today. 1/2, and you have to integrate. What is the integral of w to the 7th?
1 over 8.
1 over 8 w to the plus c. So that's 1 over 16 w to the 8th plus c. You're not quite done because what does w equal?
2r plus 4. So
1/16th
2r plus 4.
plus, and then you are 做完了. Your work is done. Your work is done. So don't forget the end phase stuff, which is like if you're going to... Okay, let w equal x minus 3. What's dw equal?
X.
dx. 1 dx, right. So you get the integral of
This is 1 over 1.
dw over w, right? What is that integral? You've done it before.
ds over ds.
No. What's the integral of w to the negative 1?
Oh, negative.
But what does w equal? Oh, it's just the absolute value of x minus... Oh, look at that. When the thing you're trying to work with is in the denominator, and only the denominator, there's a strong probability natural log is going to pop up when you're doing integrals. Okay, so I think one more hint.